Future North Korean oil must come from the U.S. and Russia. The three major oil hub structure of Rason, Nampo, and Sinuiju. 30th. North Korean Oil Industry Strategy Part 2. Keep China's valve open, buy U.S. oil, and deliver Russian gas. Creating the miracle on the Taedong River. North Korea's Workers' Party can do a market economy. Let us look at the detailed plan for diversifying energy imports, which involves establishing three major oil refining and energy hubs in North Korea: Rason, Nampo, and Sinuiju. The design principle is the decentralization of the three hubs. The three hubs are designed as independent energy centers with distinct supply sources, raw materials, beneficiary industries, and export directions. Nampo is designed as a West Sea export model based on U.S. crude oil and LNG. Rason and Chongjin as East Sea export models based on Russian crude oil and gas, and Sinuiju as a domestic distribution model for Russian crude oil and gas via China. This triangular structure structurally blocks dependence on a single supply source while supplying energy optimized for the economic zones behind each hub. As of 2024, the United States was the world's largest LNG exporter, exporting an average of 119 billion cubic feet per day under the Trump administration's drill policy. Export capacity is projected to expand to a maximum of 2.6 billion cubic feet by 2030. The share of U.S. LNG exports to Asia expanded from 26% in 2023 to 33% in 2024 and is expected to increase further by 2030. North Korea, a new source of demand in Northeast Asia, fits perfectly into this expansion strategy. The first hub is the Nampo U.S. crude oil, LNG refining, and energy complex. Across the West Sea, Nampo is 180 nautical miles from Incheon, approximately a 24-hour voyage, and about 10 to 12 days from the U.S. West Coast by LNG carrier. Its accessibility to the hinterland market is the highest in North Korea, being only 42 kilometers and 45 minutes from Pyongyang via highway. Furthermore, the simultaneous construction of the inner and outer ports of the West Sea Lock will enable the berthing of large LNG carriers exceeding 50,000 tons. This is the design plan for the U.S. crude oil and LNG procurement structure. Crude oil procurement is based on U.S. WTI West Texas Intermediate Light, low-sulfur crude oil with an API 40°. The structure will transition from a transshipment route via Incheon or Gwangyang ports in South Korea, from Cheniere Energy's Sabine Pass or Corpus Christi LNG terminals, to a direct route structure once the dedicated LNG terminal at Nampo port is completed. Initially, South Korean companies GS Caltex and SK Energy will refine the oil at their Incheon refinery and supply it to Nampo in the form of refined oil. After the completion of Nampo's own refinery, the system will transition to direct crude oil import local refining production. For LNG procurement, 20-year long-term offtake contracts will be signed with major U.S. exporters such as Cheniere Energy, Venture Global, and Bandar LNG. Referring to the case where Korea Gas Corporation KOGAS signed a contract with the U.S. company Trafigura in August 2025 for the additional annual import of 3.3 million tons of LNG for 10 years. Starting in 2028, North Korea can also secure initial procurement through indirect contracts via KOGAS, specifically through the resale of oil via South Korea. This is the phased facility configuration plan for the Nampo complex. Phase 1. During the 0-3-year period following denuclearization, one floating storage and regasification unit FSRU will be leased and moored outside Nampo port. Since the FSRU is constructed in the form of a vessel, it can begin operation within 3 to 6 months without the need for an onshore terminal. This method has already been widely applied in emerging economies in Southeast Asia and Africa and represents the fastest route for North Korea's initial LNG imports. The gas regasified from the FSRU will be supplied to the Nampo onshore gas power plant 500 megawatts class via an underwater pipeline. Phase 2. During the 3-7-year period, a modern oil refinery with a daily capacity of 50,000 barrels will be constructed. Gasoline, diesel, kerosene, and naphtha are produced using US WTI crude oil as a feedstock. The EPC engineering, procurement, and construction will be carried out by a consortium of Hyundai Engineering, GS E&C, and SK Ecoplant, and process technology will be selected from US Accenses. The process begins with simple atmospheric distillation CDU and subsequently adds hydrodesulfurization HDS and fluid catalytic cracking FCC in stages. The produced naphtha is supplied as feedstock to the naphtha cracker NCC at the Nampo petrochemical complex. Phase 3, during the period of 7 to 15 years, will expand the Nampo refinery to a daily production capacity of 150,000 barrels and sequentially add naphtha cracker 500,000 tons per year of ethylene, polyethylene, and ethylene glycol EG plants. The petrochemical cluster will be completed through a joint venture structure involving Korea's Lotte Chemical and LG Chem and the U.S. Dow Chemical. The produced plastic raw materials are supplied to manufacturers in the Kaesong and Haeju special economic zones, and exports are processed to the East Asian market via transshipment at Incheon Port. This is how Nampo structures U.S. interests. If Cheniere Energy or Venture Global directly invests in the construction of the Nampo LNG terminal or signs a 20-year offtake agreement, the interests of these companies' shareholders are directly linked to the maintenance of North Korea's denuclearization. The Trump administration has withdrawn the LNG export approval policy that the Biden administration had suspended and is actively pushing for the expansion of LNG exports under the pretext of energy security. The opening of the North Korean market creates a new hub for U.S. LNG exports in Northeast Asia, which aligns perfectly with Trump's energy hegemony strategy. An annual export contract for 2 million tons of LNG is worth approximately $1 to $1.5 billion, serving as the concrete economic basis for the energy industry lobby supporting U.S. Senate diplomacy toward North Korea. The second hub is the Rason and Chongjin Russian crude oil, gas refining, and energy complex. Rason is already connected to Kazan, Russia by land and a 54-kilometer railway, and as an ice-free port on the East Sea, it allows for year-round operations. Chongjin is located 70 kilometers south of Rason and has a hinterland industrial complex where energy-intensive heavy industries such as the Kimchak Iron and Steel Works and the Musan Iron Mine are concentrated. The core design principle is to connect the two cities with a single energy supply belt. This is a design plan for the procurement structure of Russian crude oil and gas. Initially, the fastest route for transporting Russian crude oil is via tank cars through the existing 54-kilometer Kazan-Rajin Railway. In the medium term, a new crude oil pipeline of approximately 54 kilometers from Kazan to Rajin will be constructed to replace railway freight car transport. In the long term, gas pipelines originating from the Irkutsk or Sakhalin gas fields will be developed into a North Korean hub for the Northeast Asia gas pipeline, connecting Kazan to Rason. The specific sources of Russian crude oil are the East Siberian Pacific ESPO pipelines API 35C, low sulfur, and specialized crude oil for export to Asia, as well as Sakhalin-1 and Sakhalin-2 offshore crude oil. Currently, China, Japan, and South Korea are the major importers of ESPO crude oil. If North Korea participates after denuclearization, it could gain negotiating power in price competition with Japan. Natural gas is sourced from Russia's Gazprom's Sakhalin-2 LNG offshore supply via Sakhalin Island to Rason, or from the Kazan-Rason onshore pipeline starting from the Yakutia gas field. As Russia faces an urgent need to diversify its exports to Asia following a significant decline in exports to Europe after the war in Ukraine, the North Korean market holds strategic value for Russia as well. This is the phase facility configuration plan for the Rason and Chongjin complex. Phase 1. During the 0-3-year period, we will proceed with the emergency repair and restart of the Rason Sungri chemical, which currently has a daily production capacity of 40,000 barrels and is currently suspended. Since the facility was optimized for Soviet-era crude oil API 38C, restarting operations for ESPO Russian crude oil API 35C is technically feasible. With technical support from Korea's Hyundai Engineering or Russia's Lukoil, restarting operations within 6 to 12 months is possible by replacing only core equipment such as distillation towers, heat exchangers, and control systems. Once restarted, Chongri Chemical will immediately supply diesel, kerosene, and heavy fuel oil to the Chongjin Industrial Complex and the Rason Special Economic Zone. Phase 2. During the 3-7-year period, we will complete the 54-kilometer crude oil pipeline from Kasan to Rajin and construct a new modern refinery with a daily production capacity of 100,000 barrels in Rason. The consortium of Russia's Lukoil Engineering and South Korea's Hyundai Engineering is the leading candidate for the EPC contract. The process includes crude distillation unit CDU, hydrodesulfurization HDS, and vapor distillation unit VDU to increase the yield of high-value-added products. Diesel, aviation fuel, and heavy fuel oil produced at Rason Port are exported by sea to Japan and the east coast of Korea. To optimize North Korean refining while aligning with the quality characteristics of Russian crude oil, a delayed coking process utilizing vacuum residue VR from the vacuum distillation unit VDU is incorporated. The pet coke generated by this process can be used as a substitute feedstock for coke at the Chongjin Kimchak Iron and Steel Works, thereby reducing dependence on coal. Phase 3 during the 7-15-year period will complete the Sakhalin-Rason or Kasan-Rason gas pipelines and construct an ethane cracker plant with an annual production capacity of 300,000 tons in Rason. Using the ethane and propane components of Russian natural gas as raw materials, a vertical integration of ethylene and propylene polyethylene and polypropylene synthetic resin products will be implemented. In Chongjin, an aromatic extraction facility is being constructed using naphtha from the Rason oil refinery as a raw material to produce benzene, toluene, and xylene, supplying them to meet the petrochemical demand of Korea and Japan. This is an energy supply system dedicated to the Chongjin Industrial Complex. The energy demand of the Chongjin Kimchak Iron and Steel Works is the largest in North Korea. Heavy fuel oil produced at the Rason Oil Refinery is supplied to the Chongjin Iron and Steel Works via a dedicated 70-kilometer pipeline, which will be converted to natural gas upon the completion of the gas pipeline. An energy efficiency project utilizing Russian and South Korean technology is being pursued to install combined heat and power CHP plants that use waste heat within the iron and steel works to simultaneously produce electricity and steam. The third hub is the Sinuiju Russian crude oil and gas refining and energy distribution complex via China. Bonghua Chemical in Sinuiju, with a refining capacity of 30,000 barrels per day, already operates an existing infrastructure that receives crude oil from the Dacheng oil field in China via a pipeline under the Yalu River. Currently, China supplies crude oil produced from the Dacheng oil field to North Korea through inland pipelines and pipelines installed beneath the Yalu River. The core of the Sinuiju strategy is to diversify this supply source to Russian crude oil after denuclearization. This is the procurement structure for Russian crude oil and gas via China. There are two possible energy supply routes from Russia to Sinuiju via China. The first is the supply of crude oil via the ESPO pipeline through Dandong. The Russian East Siberian Pacific ESPO pipeline is currently connected to Docking, China. From Docking to Dandong, it can be connected via China's existing oil pipeline network. From Dandong to Sinuiju, tank truck transportation is possible via the existing underwater pipeline under the Yalu River or the Sinuiju New Yalu River Bridge. This route is a method of supplying Russian crude oil to Sinuiju at the lowest cost by utilizing China's existing infrastructure. The second is the supply via the extension of the Russia-China gas pipelines, Power of Siberia No. 1 and No. 2. Power of Siberia No. 1 is currently connected to China's Heilongjiang province. If extended to Sinuiju via the gas pipeline network of China's 3 northeastern provinces, connecting Heilongjiang, Jilin, Liaoning, and Dandong, Russian gas can be supplied to Sinuiju via China. This route is a strategic design that induces China's participation by creating a trilateral structure to cooperate on North Korea's energy supply while China profits from operating existing gas infrastructure. This is the phased facility configuration plan for the Sinuiju complex. Phase 1, during the period of 0 to 3 years, the Bonghua chemical facilities will be urgently modernized. The existing daily production capacity of 30,000 barrels will be maintained, but the crude oil supply source will be switched from Daking, China, to Russian ESPO crude. Russian ESPO crude has an API of 35 degrees, which is higher quality than Daking's API of 32 degrees, thereby improving refining yields. The operating rate can be raised from the currently estimated 30–40% to over 80% simply by replacing the control system, heat exchangers, and catalysts. The refined oil produced by the restart of Bonghua Chemical will be immediately utilized as fuel for factories within the Sinuiju economic zone, for railway and road transport between Pyongyang and Sinuiju, and for logistics trucks between Sinuiju and Dandong. When combined with the opening of the new Yalu River Bridge, the re-export of refined oil from Sinuiju to Dandong will also be possible. Phase 2. During the period of 3 to 7 years, Bonghua Chemical will be expanded to a daily production capacity of 70,000 barrels. The expanded crude oil is procured via the Russian ESPO pipeline through China, and additionally, a crude oil tanker transshipment route through Dandong Port, namely the West Sea Yalu River Dandong Sinuiju barge route, is developed. The products produced are prioritized for fuel supply to mines and factories in North Pyongan, South Pyongan, and Jiagang provinces, and surplus volume is re-exported to the 3 northeastern provinces of China via Dandong. We will construct a liquefied petroleum gas LPG storage and distribution terminal in Sinuiju. LPG is the fastest energy source available for household cooking and heating, particularly for provincial cities and rural areas with unstable electricity supply. The structure involves transporting Russian LPG via railway tank cars from Harbin to Shenyang and Dandong for storage and distribution in Sinuiju. Phase 3 during the 7 to 15-year period will establish an LPG-LNG-based energy and chemical complex linked to the Sinuiju economic zone. We will install a small-scale C4 fraction separation facility to produce butadiene, isobutanol, and methanol from Russian natural gas propane and butane. This will supply synthetic raw materials to textile and plastic manufacturers in the Sinuiju economic zone while simultaneously raising foreign currency through exports to Dandong. This is a plan for a 3-base integrated supply chain operation system. It is best for North Korea to connect the 3 bases into a single integrated energy supply chain rather than operating them individually. If a structure is established where refined oil and gas produced at 3 energy hubs centered around Pyongyang Nampo to the west, Rason and Chongjin to the northeast, and Sinuiju to the northwest converge at the Pyongyang Energy Hub, an energy security structure is automatically formed in which the other 2 hubs compensate for any supply disruption at any one location. To this end, the East Coast refined oil pipeline extending from Rason to Chongjin, Wonsan, and Pyongyang, the Northwest pipeline extending from Sinuiju to Pyongyang, and the West Coast pipeline extending from Nampo to Pyongyang will be constructed in stages to connect the Pyongyang Energy Distribution Hub to a nationwide distribution network. To summarize the division of roles by energy source, transportation fuels such as gasoline and diesel will be prioritized for supply to the Pyongyang, Kaesong, and Haiju economic corridors via high-quality pipelines based on US WTI and Nampo industrial fuels such as heavy oil, coke, and LPG will be supplied to the East Coast heavy industry belt based on the Russian ESPO pipelines in Rason and Chongjin, and regional distribution diesel and LPG will be supplied to Pyongan Province and Jiagang Province via the SPO pipelines via Russia and China in Sinuiju. For power generation gas, the Rason Russia pipeline or Sakhalin LNG and Nampo US LNG will function as dual supply sources. This is a plan to maximize North Korea's strategic interests. The 3 greatest strategic benefits that this 3-base structure provides to North Korea are as follows. First, It allows North Korea to break free from being held hostage by Chinese energy. If the supply is diversified from its current reliance on a single Chinese oil pipeline to 3 sources, the U.S., Russia, and China, no single nation will be able to weaponize energy to pressure North Korea. Second, it enables the diplomatic leverage of energy imports. By providing the U.S. with an LNG export market, Russia with an Asian energy export route, and China with transit revenue from infrastructure, all 3 major powers gain economic interests in North Korea's energy supply chain. This structure itself serves as a geopolitical safety net for North Korea. Third, it generates foreign currency revenue through the export of surplus refined oil. The combined daily refining capacity of the 3 bases is 250,000 to 300,000 barrels, which is 3 to 5 times North Korea's projected daily domestic demand of 50,000 to 100,000 barrels 10 years after denuclearization. Exporting this surplus refined oil to South Korea, Japan, and China could generate an additional $2 to $3 billion in annual foreign currency revenue. North Korea's transition from a mere energy importer to a supplier of refined oil to the Northeast Asian region is the path through which the energy industry becomes the fastest engine for foreign currency generation in opening up the North Korean economy. North Korea's best interest lies in creating a state of cross-dependence where it buys oil from the U.S. and delivers gas from Russia while keeping the valve open to China. Through this, North Korea can emerge as a manufacturing powerhouse, utilizing the cheapest energy in Northeast Asia, while preventing any single country from exerting exclusive pressure on it. Next time, we will discuss North Korea's coal industry strategy. Thank you.